hydrogen atom with the Bohr radius of half an angstrom is situated between two metal plates 1 millimeter apart, which are connected to opposite terminals of a 500-volt battery. So that's the potential, the voltage between the two capacitors, the two plates, within the capacitor between the two plates. What fraction of the atomic radius does the separation distance amount to roughly? Okay, so since this is a uniform field, if we know the potential, we could find the electric field, right? Because the separation distance is related to the dipole, is related to the polarization or the dipole moment, which in turn, or the polarization, which in turn is related to the electric field. Okay. Okay, so we know that V is equal to E dot dl, right? But since this is a linear, this just becomes EL, with L being the thickness, right? So I could find now E to be, so if one of the plates is at the reference at 0, the other one would be at V at 500 volts. So E would be V over L, which would be to 500 divided by 1 times 10 to the minus 3. So this is 5 times 10 to the 5 volts per meter. Okay, so this here is the electric field. Okay, and from the electric field now, I know that the dipole moment is equal to alpha E, and since we're talking about the hydrogen atom, experimentally it's determined that from the table 1 on page 168, the newer edition, is alpha over 4 pi epsilon is 0. So alpha over 4 pi epsilon is 0. This is the experimental value, 0.667 times 10 to the minus 30. Okay, forget to multiply by 10 to the minus 30 because in the description of the table it says in units of 10 to the minus 30 meters cube. Okay, so and P is just the dipole moment of the electron cloud, right? And that would just be the charge times the distance that we are looking for, right? Equal alpha E. So that means I'm looking for the what fraction of the atomic radius does separation distance roughly amount to. So now I can solve for D to be alpha E over Q, and we just said alpha is 4 pi epsilon times 0.667 10 to the minus 30, right? Divided by Q. Okay, so this would be now if you remember 1 over 4 pi epsilon is 8.99 times, I believe, 10 to the minus 12. So this would be 1 over, so 4 pi epsilon is 1 over 8.99 times 10 to the 12, and this is gonna be 0.667 10 to the minus 30, and then Q, that's the charge of the electron, 1.6, because it's one atom, it has one electron, 1.6 10 to the minus 19. So D turns out to be okay, I forgot to put in the E here. The E was 5 10 to the 5. So there's a 5 times 10 to the 5 here. And this is 9, not 12. Okay, so this, plugging this in, I get 2.32 times 10 to the minus 16 meters. So you could see, as he says in the morale, the displacements are very minute, even on the atomic scale. Okay, so and we can demonstrate that by comparing it roughly to the atomic radius, right? So so divide that, so D over R, let's get the ratio. What did we get? 2.32 10 to the minus 16, and then divide that by half an angstrom, so that's 5 times 10 to the minus 11, we get 4.64 times 10 to the minus 6. So that means it's like almost if you do this the other way around, it's you reciprocate this 1/5 10 to the 6. So R is 1/5 times 10 to the 6, the amount of separation, on the order of 100,000 more, almost 100,000 more. Okay, so that's why these are really minute. Okay, continuing on with the problem, it says estimate the voltage. So now the question wants V, right? So now they're asking for V. You would need with this apparatus to ionize the atom. Okay, when would you ionize the atom? You would ionize the atom when the electron would have moved all the way to the periphery by an amount R. So when it's right here, so that's when D, the distance of separation, is equal to the radius R, or since we labeled it small r, let's go with small r, right? That's when would that happen, and the question is what is V, right? Okay, so we already know P is proportional to E, and we know this is in between the plates, so E is V over L, right? And this is just Q times D, and D is R, so this becomes QR, right? And so now, with L, by the way, being the same thing I used here, which is the distance between the two metal plates. Okay. Okay, so any d greater than or equal to r, that's when the electron would have escaped the electron cloud to make the hydrogen atom positively charged. That's when ionization takes place. So at the minimum, they're equal. Okay, so then V would equal LQR over alpha. Okay, so let's plug in the numbers. So we have what did we say this was? 1 millimeters apart, so that's 10 to the minus 3, and then we have Q is 1.6 times 10 to the minus 19, and then R is half an angstrom. So 5 10 to the minus 11. Alpha we said 0. Wait, did we forget? Yeah, it's good. 0.667 times 4 pi epsilon, which we already know what that is, times 10 to the minus 30. Plugging this in, we need a voltage of about 1.08 times 10 to the 8 volts. To ionize it. This is the voltage needed to ionize the hydrogen atom. That concludes this problem.